Alright, so for this particular question, we asked to find the original array of prefix XOR, and so given an integer array of prefix of size n, we have to return the array of size n that satisfies this particular condition. Alright, so to find, let's say for an input 52031, there's an output, and this the calculation that we do using the bitwise XOR operation, and so from the output we get the input, and so we are supposed to go in the reverse order, and there are a couple of hints here. And so this is sort of like a question saying that consider the following equation, like so x or a is equal to b, how then can you find x? All right, so let's tackle this particular problem here. Okay, so we have it here to find the original array. So we have our input here, let's copy our output also, and our explanation here. Okay, so this particular one is interesting. So meaning that prefix of 0 here would be our prefix, or would be an array, our array, or our answer, or our output of 0 here. All right, following what they give us. So this is what they give us, and so I'm just going to do this. All right, and so prefix of 1 now, following what they give us, we are going to have our output of 0, perform the XOR operation on that, on the next particular, on the next element. Prefix of 2 here is going to be this, then of 2 here, and so this follows in that fashion. All right, and so what do we have here? What do we see now? This particular operation, we can see that this AR of 0 is prefix of 0, and so to rewrite this second one here, I can just, let me copy this one here, let me just put it here like this. So we know AR of 0, so AR of 0 is the prefix of 0, so I can just replace this with the prefix of 0 here. All right, so this and this is equivalent. All right, and so once we come here also, now AR of 0 so AR of 1 is my prefix of 1, and that's the same thing here. So AR of 0 so AR of 1, so in AR of 0 so AR of 1. So I can say that, let me copy this and replace all this with the prefix here of 1. All right, so we can see a flow here. So it means that the prefix of I equals the prefix of I minus 1. So I minus 1. So for I greater than 0. All right, so once we leave the 0 index and we start at the I, this is the particular trend we notice. Okay, so meaning that our prefix of 3 here, judging from the trend, is going to be a prefix of 2, then array of 3 here. Okay, so my prefix of I is equal to the prefix of I minus 1 modulo, yes, sorry, so ARR of I, the particular index that we are on. All right, and this is very interesting. All right, so I can see this is like a general case. All right, so let's understand some XOR properties here. And so with XOR properties, commutatively we can say A XOR B is equivalent to B XOR A. All right, so that is a commutative property, which says that A XOR B is equivalent to B XOR A. All right, let me just bring that here. All right, an associative property also says, so A XOR B XOR C is equivalent to, so let me do this, A XOR B, all these operations XOR C is equivalent to A XOR the operation B XOR C. All right, and an identity property also says A XOR 0 is equivalent to A. and an inverse rule also states so A XOR A is 0. All right, so these are the XOR properties that we have. So in our general case, we can commutatively say that our output here is equal to prefix of I XOR prefix of I minus 1 over here, and this is the general case that we have here. Is the same thing. So this one is the general case that we have on top here. All right, so A XOR B is equal to C is equivalent to saying so if I have this, it means C XOR B equals A. All right, so I can just bring this one down here for members to see. So A XOR B is equal to C, then it means C XOR B is equal to A based on this rule. And this actually helps in something like if I'm performing swapping. All right, so swapping without a temp variable. All right, swapping without a temp variable. Mostly when you're performing swapping in programming, mostly what we do is we keep let's say if I have int A is equal to 5 is equal to 9 and int B is equal to 20 and I want to swap this, what mostly I do is, so let's say you have int C is equal to A and now A is equal to B and now B is equal to C. Alright, so you can perform swapping without a temp variable, that's the C, using the XOR operation. And how you can do that is, so let's say if I have let's say an int, I'm doing an int A is equal to 9 and then int B is equal to 20, I can be able to swap this. That it doesn't point to the same memory address for sure, right? I can be able to swap this without a variable, and the way you do that is A is equal to A XOR B, then B now is equal to B A XOR B. All right, then A now is equal to A XOR B. All right, so A is equal to A XOR B, so B is equal to B XOR B is equal to A XOR B means that this particular A here, which is A XOR B, so this one is equivalent to A XOR B. At this point, all this is referring to A XOR B. All right, so I'm just taking this. I've first of all established that my A, let me just take this from there, my A is equal to A XOR B here, and so my B now is equal to A XOR B, which this A here means over here A XOR B over here like this. And so what I have now from my properties, from my XOR properties, I can be able to see it's A XOR B XOR B. All right, so my associative, remember the combination of or the operation of A XOR B XOR C is the same as A XOR the operation of B XOR C. All right, and with this B XOR B, you can see from here A XOR A is equal to 0, and so this one becomes A XOR 0, and A XOR 0 from my inverse property becomes, sorry, from my identity property becomes A. All right, so that this is the inferred meaning over here. All right, from this, the inferred meaning is I now have my A here, and my A was my A is A XOR B, so this is my A here, which was A XOR B here, so this one is equivalent to A XOR B XOR, and now my B that I calculated for over here returned A over here. All right, so all this refers to this A over here, and this B returned A from the previous line, from line 54. All right, so this is equivalent to saying, remember my associative prop, I can say A, this one is equivalent to A XOR B here. So my A XOR A from my inverse operation gives 0, so this is 0 XOR B, and my 0 XOR B is equivalent to saying for my commutative prop, b XOR 0, and b XOR 0 is the same as for my identity operation, same as b. All right, so this is how you can perform like something like a swapping. All right, and that's it for another. And we can talk more about it. Okay, so if I'm supposed to go to gshell, let's try it out. Okay, so if I have int a is equal to 9 and I have int b is equal to 20 and I want to swap this, so I basically say a is equal to a XOR b, then b is equal to a XOR b, then c is also equal to a XOR b. No, not c, sorry. A is equal to a, because I want to swap without a temp variable. So we just got to a XOR b, and so you end up saying, so a becomes 20 and b becomes 9. So a initially was 9, now a is 20. So that's how you can perform swapping. All right, so we will go back to our code. So this is the general case. Now to find our output, we just do this for I greater than 0. So that is, we'll go ahead and implement that in Java. So I'm going to copy this one right here. All right, so my int AR, this is actually going to hold my results. Let me just do this. So my result is actually going to be here. This is going to be a new int of the length of pref, so pref.length. All right, so pref.length, let me just put this here. So int pref length is equal to pref.length, and I'll just put here the pref length here. All right, and so we know this kind of rule for our index 0, and so my results of 0 at more the elements at 0 is the same as the prefix at 0, and so that is done. And for every element, this is the general key that applies to it. So I'll just go ahead. So for int I is equal to 1 now, because index 0 has been taken care of. I is less than the pref length, and we increment I, and we basically go and copy the general keys here. So that is our general keys here, and we just return the answer, which is ARR. All right, and so this is my test case here. I'm just using the test keys from here from example 1, and so let me run my test case. Alright, we didn't get any errors, so I think we are good. Here. I'll copy everything, then I'll head over this point here, and I'll just submit the solution. Okay, so we have 46 out of 46 test cases passed. Okay, so that is a good step. Alright, so with this, we do the same for Python 3. So I just select my Python 3 here. Let me just copy this. Just present a solution for Python 3. Alright, just take this cell. Alright, so let me just let my n represent the length of the prefix, and my result is ARR. Let me just construct my results times n, which is the length of prefix list, right? So we've already established the condition, or from our inferred solution, we see that the prefix here is equal to the prefix at index 0 is equal to an array of 0, and so that's the same thing here. So the array of 0 is equal to the prefix at 0 here. Alright, and so for I in range, I start from 1 to my length of my prefix, And so the same thing here. Alright, so my array at I is equal to my prefix at I, so the prefix at I minus 1, and I just return my results. Sorry. Okay, so that's the equivalent. We can test that in Python. So there's a test case. I can just run that. Py, and it's run without any issue. So I'll just go and copy my solution here, copy everything, head over, present this. Okay, and it submits my solution. Okay, it takes one position argument. We got the self here. Okay. Alright, so we see 46 out of 46 test cases passed, and we are done.